Okay, so we have projectile motion. Okay, अच्छा जी, प्रोजेक्टाइल मोशन का हिसाब किताब ऐसा है कि प्रोजेक्टाइल मोशन का हिसाब किताब ऐसा है कि हमने जो वर्टिकल मोशन पढ़ा और हमने जो हॉरिजॉन्टल मोशन पढ़ा, हमने उन चीज़ों को मिक्स करना है, सही है। तो उससे हमारे पास प्रोजेक्टाइल मोशन बन जाएगा, सही है। यार एक सेकंड दो जरा, मुझे कुर्सी चेंज करने दो।
ओके।
ओके, सो हमने बेसिकली अभी तक हमने ये कॉन्सेप्ट पढ़ा कि भाई हमारे पास एक मोशन ऐसा है कि जिसके अंदर हमने ऑब्जेक्ट को आगे मूव करवाया, सही है। ओके, और एक मोशन ऐसा था कि जिसके अंदर हमने ऑब्जेक्ट को ऊपर मूव करवाया, सही। सो एक मोशन के अंदर ऑब्जेक्ट ऊपर गया और एक मोशन के अंदर ऑब्जेक्ट आगे गया, सही है। ये दो मोशन हमने देखे, सही। ये हमारे पास था हॉरिजॉन्टल मोशन। ये तो बहुत छोटा क्यों लिखा रहा है, हॉरिजॉन्टल क्या होना चाहिए। अच्छा जी, सो हॉरिजॉन्टल मोशन, सही, एंड दिस इज द वर्टिकल मोशन, सही। जब हम इन दोनों को कंबाइन करेंगे ना, तो हमारे पास जो चीज़ बनेगी दैट इज गोइंग टू बी द प्रोजेक्टाइल मोशन। ओके। अच्छा जनाब, और ओके, और प्रोजेक्टाइल मोशन इस तरह से होगा कि अगर आपके पास एक ऑब्जेक्ट है एंड इफ यू लाइक थ्रू द ऑब्जेक्ट, सही है, सो वो यूं मूव करेगा एंड इट विल लैंड राइट हियर, राइट। दिस इज गोइंग टू बी द प्रोजेक्टाइल मोशन, राइट, सही है। अच्छा, अब इसके अंदर like we have to discuss the whole analysis, or we have to do the whole analysis of projectile motion, like the kinematics analysis, and as well as एक थोड़ा सा मैथमेटिक्स हमने इसमें इन्वॉल्व करना है। सही है, सो लेट्स स्टार्ट विद इट। अच्छा, सबसे पहले अगर हम इसको स्टार्ट करें विद द डेफिनेशन, सो projectile motion is going to be projectile, it is going to be the motion under the influence of gravity when an object is thrown, when the object is, you can say thrown, you can say launch, or you can say something, when the object is launched um, with some velocity at some angle, ओके। अच्छा जी, अब इसके अंदर हमारे पास वी डिस्कस थ्री थिंग्स, so the first thing is um it should be under the influence of gravity, right? This is the first thing, right? And it should be launched with some velocity, okay, and at some angle, okay. So The angle can be zero, but angle can be like zero from 0 to 90, right? If it becomes zero, so the object start from the horizontal motion and become projectile. If you take the angle as 90, then it will be pure vertical motion, right? So अच्छा तीन cases हमारे पास के तीन चार cases के possible हैं, right? So um, let's say if we have the object. So if we have the object, okay, and let's say we launch it with some velocity, with some initial velocity v, okay, and the object covered this path, okay, the object covered this path, okay. So this is the first concept, okay. Like we launch the object with some initial velocity, okay, and the object cover the object is under the influence of gravity and it is launched at some angle, okay. You can consider this angle right here, theta, okay. So you get now this is the first case. The second case is if you are launching the object horizontally, right? Let's say you have okay, let's say you have some edge or something, okay, and there's the object, and you are launching the object. Sorry, this way, okay. So you basically have launched in this direction, okay, horizontally. So you get. And the third possible case is if you launch the object exactly at 90 degrees, okay? So the third case is, mm, okay, so the third possibility is that it is like exactly 90 degrees upward, okay, and the motion follow this path, okay? So these are the three possibilities. Okay, so the first one is where you consider the angle theta that is like greater than 0 but less than 90, okay, and in the second case you consider the theta equal to 0, okay, at this starting point, okay, and in the third case you have considered the theta is equal to 90 degree, right? So this is going to be a completely vertical motion, okay, this is going to be completely vertical motion, vertical motion, right? And we discuss all the calculation and all the concept in the previous classes, okay? While these two are the projectile motion, okay? So the first one is half projectile motion and the second one is the full projectile motion, okay? Um, these are the projectile motion, okay? Now, so we have to consider the second and third case, right? And in both of the cases, or you can say in one of the case, the first case, we'll have two different possibilities, right? Or three different possibilities, right? So the and those possibilities are that if you launch the object, I'm just copied down. So yeah. So this is the first case, okay. The second case would be, and the third case would be. These are the two possible cases. Let me just change it down a bit. Okay. Acha. So this is the first case. So your first case. Okay. And the second case would be from where you launch, you didn't end up landing at the same point. You may land at a higher ground. Okay. So, okay. So this is the second concept. Okay. This is the second concept, right? And the third concept is you land at a lower ground. Okay. Lower ground. Okay. So if you try to understand the difference between them, so in the first case, let's say if you launch the object with a velocity v, let's take it as 10. Okay. So when the object cover the whole journey, and it will be when it will be about to land, it will have the same velocity with which it was being launched. Okay. So okay. But while in the second case, acha, by the way, and in the first case, like if you break the motion into two, so exactly the two half of the motion will be symmetrical, will be like the mirror image of each other, right? Except some quantity. And in the second case, since you're launching the object from the lower ground and it lands at a higher ground, so there will be difference in the final velocity. Okay. And there will also be the difference in time, right? And yeah, these are the two things, right? And also displacement. Okay. And in the third case, there will also be the difference in time and displacement, right? And speed as well, right? Because in the third case, the ball cover more distance, which mean it move more under the gravity. So this mean the ball will have greater speed. Let's say अगर आपने 10 से उसको launch किया, so ball will have like a speed greater than 10 while it would be about to land. Okay, so these are the three possible cases. So we have to discuss the first case and the second case, the third case a bit, and we have to consider this one as well. Okay, so these are something that we need to discuss. Okay. Acha ji. So let's try to understand uh, vectorially what's going on in the projectile motion. Okay, so let's say if we have the projectile motion right with us, copy and paste. Okay. So the ball will be. Acha, always keep in mind. We consider in the motion in the projectile motion definition, we only consider the force of gravity as the only force acting on it. Okay. There are no other forces. Okay. No air resistance, nothing. Okay. Please be careful because this is going to be something that would be like cause you प्रॉब्लम, क्योंकि कभी कभार जो है ना वो इसके अंदर अगर वो नहीं होता आपके पास, लाइक प्रोजेक्टाइल मोशन के अंदर एयर रेजिस्टेंस को अगर आप कंसिडर करोगे, सो इट वुड लुक डिफरेंट. ओके. सो या, खैर. वेट, ये हो गया पूरा. इट शुड बी विद ब्लैक. ओके, डन. अच्छा जी, सो हम ये कंसिडर कर रहे हैं कि एयर रेजिस्टेंस और नेग्लिजिबल. एयर रेजिस्टेंस इज negligible. Negligible. Okay, this is a very important thing. Okay. Now, if we have the object and let's say we launched it with the velocity v, right? And we can break this velocity into two of its component. Okay. So आपको पता है कि if you have a vector in this direction, let's say if this is a vector, okay, so it will always going to have two component. Okay, one in the horizontal direction. Okay, and one in the vertical direction. Okay, is that clear? अहमद, ये थोड़ी सी नई चीज है, प्लीज इसको समझना. Okay, these are the two things, right? So if you have the velocity v, this is a theta. Okay, this is a theta, and this is a velocity v, right? Okay. In this case, in the case of projectile motion, when we launch the object, okay. अच्छा जैन, हम ये सिर्फ ये हमने देखा है कि वर्टिकल मोशन में लास्ट क्लास में डिस्कस किया था. इन द प्रीवियस क्लास वी डिस्कस हॉरिजॉन्टल मोशन, देन वर्टिकल मोशन एंड देन प्रोजेक्टाइल मोशन इज बेसिकली द कॉम्बिनेशन ऑफ द वर्टिकल एंड हॉरिजॉन्टल मोशन, राइट? एंड वी हैव जस्ट स्टार्टेड. सो थोड़ा सा फोकस करोगे इंशाल्लाह विल गेट व्हाट वी आर अप टू. सही. सो Acha, so whenever in the projectile motion, whenever you see anything like this, right? Because we are talking about we are considering the velocity, and velocity is a vector quantity, and vector quantity always going to have some direction. So, and to solve the vector quantity, we always need to break that vector into a horizontal and a vertical component. Okay, clear? Is that clear, Ahmed? Then is that clear?
Yeah.
For example, for example, if you have if you have the vector in this direction, okay, let's say 10 units, okay, and let's say it is at an angle of 30 degrees. So we know that this vector is basically formed from the two vertical and horizontal vectors, okay. So if I ask you to find those two, so what will you do? You just break them into vertical and horizontal, okay. And अच्छा जी, now we have the trigonometry. um, so trigonometry लगाओगे तो क्या बन जाएगा? 10 cos 30 and 10 sin 30. Is this clear? Is there any problem? मैंने बिल्कुल डायरेक्ट कर दिया. You can use SOHCAHTOA or you can use, some people have curly bracket, whatever mantra you remembered.
Wait, sir. So when do we use this?
Always when you have the velocity like this, okay?
Oh, okay. Okay.
Like whenever the velocity, basically in projectile motion only, when you project the object, when you launch the object with some angle, like the velocity will always going to have some angle. So you have to replace or you have to remove that angle by breaking down the velocity into its vertical and horizontal motion, okay, or vertical and horizontal velocities, okay. Is that clear? Because we discussed earlier that projectile motion is basically the combination of two motion, a vertical and a horizontal motion, right? This means if we have this motion and this velocity, so this velocity should have some vertical velocity and some horizontal velocity, right? Like a Pythagoras theorem, right? Is that clear? Yes, guys.
Yeah. Yeah.
Uh, Acha, by the way, you can also make this into one other way. Okay. So if we have the vector like this, okay, so you can also make the two vector component, one in this direction and one in this direction. Okay. Both are the possible um, way of drawing the vector. Okay. It's up to you. For this case, I would rather refer you to or recommend you to use this one. Okay. But this one would be like easy to solve like mathematically. So whatever easy for you, just go ahead. Don't worry. Okay. Fair. So in this case, we are consider the air resistance negligible. Okay. So if we break the motion into two, so one component will going to be this component, the horizontal component, horizontal component, and one will going to be the vertical component. Okay. So the horizontal component is going to be v cos theta, and the vertical component is going to be v sine theta. Okay. Is this clear? Okay. This is v vertical and this is v horizontal. Okay. And this is let's say v resultant. Okay. Or v final, whatever you want to say. Okay. Is that clear, guys? Rahana, bolo, please. This is something new to you.
Yeah. Mm.
Perfect. Now, if you imagine the object in, let's say, two or three different positions. So this is the first position. Okay. This is the second position. Okay. This is the third position. Okay, and this is the last position. Okay, these are some positions that we have. Now, let's see. If I consider the first position, so on the first position, I'll have the vertical component. अच्छा, by the way, sorry, मैंने इसका vertical नहीं बनाया. So the vertical component for this case would be like this. Okay, and at this point, at the first point, the the resultant would be in this direction. Okay, it would be in this direction. Okay, and the vertical component is going to be smaller, right? While the horizontal component remains the same. Okay, the second point is referring to the point of the maximum height. So at maximum height, you know that the vertical velocity is zero, right? Not the horizontal, only the vertical velocity is zero, right? So at that point, we'll consider the vertical velocity zero. Okay, so we'll only have the horizontal velocity left at this point. Okay, and it should remain the same, right? And why I'm keeping the horizontal component same? Because we have no air resistance, horizontal, no air resistance, and no backward force resisting the motion, or no forward force accelerating the motion, horizontal, in the horizontal direction. Okay, so in horizontal, we will always going to have a constant velocity motion. Okay, is that clear, guys? At the third point,
Yes.
the horizontal velocity remains the same, as we don't have any horizontal motion in horizontal acceleration, and we have some vertical motion due to gravity, so it will be downward. Okay, and in the last point, it will have the same horizontal and the same vertical as well as it was in the starting or in the beginning, right? Perfect. Is that clear, guys?
Yeah.
Now let's try to understand the concept of the vertical and horizontal motion. Okay, so okay, we have the vertical motion, the vertical. Okay, let me connect let me start with the horizontal first. Horizontal motion. Okay, अच्छा जी. In horizontal motion, first thing first, since no, yeah, come on, since no forward and backward forces are there. ये देख क्यों इतना छोटा हुआ है? ये मजा है ना. No, wait, and no backward forces are there, so object will move with constant velocity. And Bachu, can you guys recall which formula we use when the object moves with a constant velocity? Anyone? Yes, anybody?
Could you say that again? I didn't hear you.
Which formula we use when we have the constant velocity?
Um,
Anybody?
Displacement upon time.
Good. So we have to use velocity is equals to displacement upon time. Okay. But be very careful, this displacement is going to be horizontal displacement. Okay. And this is the only formula that we will have to use in the horizontal portion of the projectile motion. Okay. Right. For the vertical motion, for the vertical motion, since the object is moving up and as well as moving down, and it is under the influence of gravity, so we have to use the equations of motion. Okay. So like if you consider the vertical motion separately, so the ball is moving up, okay, and it's coming down, okay. So negative, okay, so up and down, okay. So while the ball is moving up, you will have you will have something to be remembered. So initial velocity is going to be it will going to be the horizontal vertical velocity of the projectile motion, which was v vertical, sorry, v sine theta, okay, v sine theta, okay. While for this case, this velocity will going to be v cos theta, okay. Now this is the first case. The second case, at max height, at max height, only vertical velocity will be zero, okay. Please keep in mind, very important point. Okay, in projectile motion, we'll only have the vertical component of the velocity zero, but the net velocity will not be zero, okay. And so is the kinetic energy. They'll confuse you in many questions, okay. So please be aware, okay. And the third thing is acceleration is going to be negative when moving up and positive when moving down, 9.81, okay, meters per second, okay, squared. And these are something, okay, we can use, acha, very important thing. There's one quantity that relate the vertical and horizontal motion. Can you guys tell me क्या हो सकती है? There's one quantity that relate the vertical and horizontal motion. Can you tell me? Acha, by the way, S is going to be the displacement. Okay. Okay. By the way, अच्छा जस्ट एक सेकंड दे दो, जरा अजान याद है फिर उसके बाद पढ़ते हैं. अच्छा जी, आ जाओ. सो मैंने यहाँ पे ये बतानी है कि डिस्प्लेसमेंट क्या होगी. ओके. सो इन दिस केस, in the first case, the height is going to be this much. Okay. The height is going to be this much, but the displacement is going to be zero because it is reaching at the same height again, right? So in the second case, the height is going to be that much, but the displacement is going to be like the net difference. Okay. So you started from this point and you end up at this point. So what will be the difference? यहाँ से आपका ये हो जाएगा, ये displacement हो जाएगी. Okay. This is going to be the displacement. Okay. And in this case, this is going to be the displacement. Okay. Be very careful about the distance displacements. Okay. Because then you have to use S equals to ut plus half at squared. Okay. And in S, you have to consider the displacement, not the height. Okay. Very careful. In S, you have to consider the displacement and not the height. Okay. So for that, you should have the clear idea what is going to be the displacement, what is the height. Okay. Now let's move on. Okay. So the displacement is done. Okay. One parameter that is common in the vertical and horizontal motion is the time. Okay. So time is going to be same in vertical and horizontal motion. Okay, like if you have the things given for the vertical motion and they're asking you to find a quantity in the horizontal motion, so you just need to find out the time from the vertical motion and then you put the time in, and you'll have any one quantity or two, like from the displacement and the velocity, and you can find out the third one. Okay, क्लियर हो गया? अच्छा जी, चलो ये हमारे पास हो गया प्रोजेक्टाइल मोशन की कैलकुलेशन से रिलेटेड थोड़ी बहुत चीजें. ओके, नाउ let's try to understand it with a question. With a question. अच्छा जी, प्रोजेक्टाइल मोशन के अंदर ऑल इसके अंदर और कुछ है? नहीं है, नहीं है, नहीं है, नहीं है, नहीं है. फाइन. अच्छा, बाय द वे मैंने अभी वो नहीं करवाया कोई. सही है. मैंने अभी कोई ग्राफिकल रिलेटेड कोई चीज़ नहीं करवाई. इट इज़ इंपॉर्टेंट, मुझे करवाना है. एंड थोड़ी बहुत एक्सपेरिमेंटल रिलेटेड चीज़ें वो भी मुझे करवानी, बट वो नेक्स्ट वीक होंगी. फॉर नाउ इट्स जस्ट गोइंग टू बी योर होमवर्क कि आप लोग का जो है ना प्रोजेक्टाइल मोशन होने वाला है, लाइक वर्टिकल और हॉरिजॉन्टल एंड प्रोजेक्टाइल मोशन होगा. सो लेट मी हैव इट. खुल जा भाई, खुल गया. ओके. अच्छा जी, लेट मी टेक यू टू द. आ जाओ. अच्छा जी, तो लेट्स स्टार्ट विद. Okay, so this is a projectile motion question. Okay, Ahmed, can you please read the question?
Okay, a golfer hits a golf ball so that it lands at a distance of 250 meters from the golfer. The golf ball is given an initial velocity u at an angle of 40 degrees to the horizontal. Explain why t is equals to 250 upon u multiplied by cos 40 degrees is the correct expression for the time of flight of the golf ball. Assume the ground is horizontal and that there are no wind or air resistant forces.
Okay, so basically they have given you the assumption as well. Okay, and you have to show them by using the equations. Okay, so आगे भी करते हैं. अच्छा जी, so अच्छा, अगर आप इसको थोड़ा सा सिनेरियो बनाना चाहो, so the scenario is going to be like this. Yeah, we have a ball and the ball is hit with a velocity of 40 degrees. Okay, with an angle of 40 degrees. Okay, and it covered a horizontal distance of 250 meters. Okay, 250 meter. सही हो गया. We don't know the initial velocity u. Okay, and अच्छा जी, so we have to find the time. Okay, so we know that the time is something that is common in the vertical and horizontal motion. Okay, so if we use since we can just do it with a horizontal motion, so speed is equals to distance upon time we can use. Okay, and speed in this case is going to be u and cos theta, right? Cos 40. अहमद, ये बात समझ में आती है ना, कॉस और साइन का क्या प्रॉब्लम है? राइट, ये समझ में आता है ना? इज इट क्लियर? ओके, एंड डिस्टेंस इज 250. So you can make u cos 40. सही हो गया. So this is something we showed. Okay, now let's move on. अच्छा, ये हो गया. आगे आ जाओ. ओके, ये रीड कर लो प्लीज. हम्म.
Calculate the initial of the
ओके, हम क्या कर सकते हैं भाई इनिशियल वेलोसिटी निकालने के लिए? We have the horizontal distance, and they have given us a velocity. And okay. Any idea?
Should we use the equation f is equals to ut plus 1 upon 2 at square?
Ut plus 1 over 2 at square. अच्छा जी, land at distance from the golfer. Okay, so the displacement is zero, right? Because इन्होंने कहा कि the golfer hit the golf ball so that it lands at a distance of this much away from the golfer, okay, and it is landing at the same horizontal ground, okay. So if we consider s is equals to ut plus half at squared, right? So by the way, we have the displacement zero. The initial velocity is also unknown. The t is also unknown, right? We can substitute the value of t in it. Okay, so u is okay, so u is going to be the vertical velocity. Okay, u is going to be the vertical velocity because in this case this should be the vertical. Okay, and vertical velocity over here is u sine 30 sine 40, right? Making sense, right? And horizontal velocity is going to be what? अच्छा, time is just हमने जो भी निकाला है 250 divided by u and cos 40. बच्चों ये क्लियर हुई बात? Is this step clear?
Yeah.
And then 1 over 2, and since we launch it against the gravity, so negative 9.81. Okay, and the time is going to be 250 over u cos 40. Okay, now we have only one unknown, so let's try to solve. Okay, so in this case u and u goes off. Okay, and there'll be sine 40 divided by cos 40 into 250. Okay, and then we have minus sign, and then 9.81 divided by 2 gives you 4.905. सही हो गया? And 250 and then divided by u cos 40. Okay, so if you just do the cross multiplication, so you will get sine 40 over cos 40 times 250. Okay, I'm taking 4.905 and the whole thing to the other side, so this become equal to 4.905. Okay, times it by 250. अरे यार, come on, 250. यार, what the hell? Hmm, क्यों नहीं चल रहा यार? एक सेकेंड. Okay, times it by 250. Okay, and divided by u cos 40. Okay, so this and this 250 goes off, cos theta and cos also goes off, and we'll be left with u over here and 4.905 divided by sine 40. Okay, can you guys please calculate for me?
8.3.
How much?
8.34.
8 point. अरे यार, okay. 8 point. अच्छा जी, एक सेकेंड, लेट मी सी द आंसर कि इनका क्या आ रहा है. 8 ये आ रहा है. Wait. Okay, they are getting u as 49 or something 50. Okay. साइन 40 और कॉस 50, सही, हमने सही किया है। नो, दे आर गेटिंग 50, और इनके 50 को हमें 1/2 × t² यू साइन 40 -9.81 हाफ इंच। यार किया तो हमने भी यही है, उन्होंने भी यही किया है। ओ मैन, यार स्क्वायर गुम हो गया ना, स्क्वायर रह गया यहाँ पे। सही है, t² नहीं, स्क्वायर नहीं हुआ। सही है, जब ये यहाँ पे आएगा मैंने इसको इसी वजह से कैंसिल आउट कर दिया। सही है। अच्छा जी, सो कॉस 40 सही है टाइम्स 250, सही, और ये हो जाएगा स्क्वायर, और ये पूरा हो जाएगा स्क्वायर। सही है। सो अच्छा, स्क्वायर से ये तो क्या कैंसिल हो जाएगा, एंड चूंकि इस होल थिंग पे स्क्वायर है, सो इट विल बी, वेट, अच्छा जी, नाउ हमारे पास हो जाएगा साइन 40 ओवर कॉस 40 इज इक्वल्स टू 4.905 टाइम्स 250, सही है, डिवाइडेड बाय यू स्क्वायर एंड कॉस स्क्वायर 40, राइट। सो ये कॉस स्क्वायर से इससे ये कैंसिल हो जाएगा, राइट, एंड यू कैन ब्रिंग कॉस 40 टाइम्स बाय साइन 40, ओके, या चलो आप इसको नीचे रख लो। सही है, like you can bring u square to the other side, u square to the other side, and 4.905 into 250 divided by sine 40 and cos 40, right, and you can root it then to remove the things. So now I'm getting 49.9, okay, that would be rounded off to 50, okay. Guys, ये तुम लोग कहाँ आ रहे हो? Yes.
1 second. 9. Mhm. Mhm.
Yes guys, क्या हुआ?
So I'm getting 49 just.
You're getting 49,
Oh,
सही है,
wait. Uh,
it should be around 49 point, it is 50 or 49.9, both are acceptable.
wait. Wait. Okay, I think it's okay. So do you have more of these questions like I can practice after?
Yes, I have a lot.
Mhm.
Okay, please note down your homework. मैं जरा इसी को जो है ना वो करता हूँ. Let me show you some question that you can practice. Skip the graph one for now. Okay. Um. Okay. This is the question. Same. You have to practice. Okay. It's although an MCQ, but you have to practice this one. Okay. Skip the graph one and try this one. Question number 10. Okay, this is a question number in my worksheet. Okay, so this is a question number 10 of my worksheet and question number 13 of the paper. Okay, So okay. So just write it down. Question number 4 and question number 10. So yeah. And then you can skip the last part because the last part required some explanation of the air resistance जो कि अभी हमने नहीं की है. It's calculation से related नहीं है वो. सही है. And you have to do this one. 14. Write down 14. 4, 10, 14. Okay. And then okay. Try the 16. Okay. 4, 10, 14, and 16. Okay. And you can practice for 25. You can practice 25. Okay. And you can practice 28. Okay. And yep. And you can practice the last question. Okay. 31. Okay. So I think you have a lot of questions, like 6 to 7 questions at least. Try each and every question out. Okay. Before the next class on Friday, try each. I want every question. कि मुझे उसकी प्रैक्टिस चाहिए, लाइक अटेम्प्ट होना चाहिए, राइट. It's not necessary कि तुम्हारा आंसर सही आ रहा है नहीं आ रहा, doesn't matter, but you just need to attempt it. Just give a try. Okay, I'll send you the marking key as well. Okay, so just give it a try. Okay, and yeah, that's it. So I'm ending the class. I'll send you the worksheet after the class, and try to solve the questions that I've marked. And in the next week, inshallah, we'll cover the whole thing. So yeah, whole kinematics, and then we'll move on to the next chapter, momentum. Okay. Momentum is going to be the smaller one. We'll complete in like 1 week. Okay. So that's it for today. We'll meet you in the next class. Okay. Till then, take care, guys. Allah Hafiz.
The office.
Allah Hafiz.
So just one thing.